All right. Let's see. Do we... Uh-oh. What happened to the picture? Oh, no. What's going on here? Ah, hey, guys. Hey, if you can just hold on just a second here. I am trying to see what's going on with my video here. It looks like I may have to restart OBS because something has gone drastically wrong here. That's why I started this a few minutes early. I just got done rendering a video and it looks like something has messed up all my video settings here. So I will be, just give me just 2 seconds, guys. Don't go anywhere. Don't go anywhere. Yeah, I know. I broke it. You see how it's backwards? I don't know. For some reason, my main camera just dropped out, and now my other camera is the picture's backwards. So something has happened with OBS here. So I got 1 minute left before my official 3 o'clock. Don't go anywhere, guys. I'll be right back with you. All right, let's see here. I'm not sure if this is still connected. Well, it looks like it's back up and running. Wow, what a disastrous mess that was. I shot a video on a repair of a Smart 5 today, and it took almost 2 hours just to render the video, and I think it may have, this poor computer just didn't like to go from rendering a video to doing a live stream. So just in case, All right. So hopefully, all right. Hopefully I got this all figured out now. Hopefully I didn't lose all you guys. All right. So I got my camera back. Yes, I got it back. I'm not sure what happened there, guys. I do apologize for that. So now that I'm about 16 minutes behind schedule, we'll go ahead and start on this Stetsom Vulcan 8,000 watt 1 ohm amplifier. This is going to be your hello. Sorry for any delays on this video for anyone that's coming back. Hopefully Daniel and Steve, they make it back in. I do apologize for the computer glitch that just took out all my cameras. So I'm back though, got the computer fired back up. So we should be good to go on this again. So I have inspected this prior. It's been a little while, but let me see what my note here says. We have, looks like we have some drivers, power supply. Looks like this is going to be a power supply rebuild. This is going to be one of your typical Brazilian style amplifiers, which I don't know if you do, when you do these so often, you kind of get used to getting these done. So hopefully we can keep this video stable. Hello from the Caribbeans. Oh, boy, I bet the weather is fantastic there in the Caribbeans. I would assume it's really hot here. We're in the 100 degrees here now, so here in central Washington, it's quite warm outside. Excuse my big hands in the reach of the video here. I'm gonna pull this cover off and see what we got going on. So when amplifiers first originally come, they come in and I give them a diagnosis, and then I give the owner a quote for the repair. So then I don't proceed until the quote is approved by the owner. And my typical turnaround time at the time of this live stream that I'm doing today is about four to 5 weeks. I'm slowly catching up on the summer's competition board. So the camera is going haywire. The camera is going haywire. Yeah, my computer is acting up. So if you guys notice anything funny going on, because I don't see anything funny on my screen going on. So Mohammed, hey, how are you doing? Can you play to have live about how to use a scope? Oh, hey, did you ask before about oscilloscopes and signal generators? I was thinking about you on that, and I can give you some general ideas on how to use the scope, but I do have to mention that it really does depend on the scope that you have. and your knowledge about scopes. But I can sure give you an idea on how scopes run. So and if you guys are able to let me know to see, making sure that the video is still coming through. For some reason, the bar across the bottom on OBS is not showing me my my streaming data. So I don't know if I have any dropped frames or anything because it's not there. So what we're going to do is we're just going to peel this board out. And you could probably already see that this power supply has had a tragic failure. These use the 1404s in the power supply. This looks like a around the same build as like a 8K tar amps. Hey, there's Basehead. Hey, thanks for joining in. There's Jesse. Hello, hello, hello. Again, I do apologize for any issues with the stream. Again, on my OBS here, I cannot see if I have any dropped frames or not. I don't know what is going on today with the computer. I spent an hour or so this morning shooting a video on the repair of a Smart 5 flawlessly. So I don't know why all of a sudden I'm starting to have video issues on this. Probably because when I put the video together, probably the cache, I'm not sure. Something is messing with the poor computer here and its capabilities. I go and get a better camera setup, and then I turn around and have computer problems. What's that called? Murphy's Law? Yeah, these transistors got so hot that looks like where the die is and the transistor actually melted and flattened out because the transistor itself is in pieces. So hopefully everyone is staying cool out there. I know the weather's heating up here in Washington. And of course, if you guys have any questions too, I'm always more than happy to answer questions. That's one of my things that I love, is to help teach and educate. That's what I've done pretty much my whole adult life, is educate and teach. I am I was a industrial electrician for many years, from small jobs to big jobs, and have trained many people, and it's just one of the things I love to do. So if I can help teach someone about electronics, then more power to the people, I guess. So of course we got to get this board out of the heatsink to be able to work with it. I think this one's going to be a relatively easy fix. The only bad problem, the only downfall on a fault this severe is the short that goes back to the MCU or PIC, the programmable IC. Sometimes that short goes back and damages that chip, and then you don't have drive. So the biggest thing is pull this thing apart, get the transistors out that are all burned up, and bump it with some power to see if you get any signal at the gates. I know where's the power tools, right? I should have a little drill, but That'll make a lot of noise. So anything in particular, Mohammed, that you want to know about scopes? Or are you just looking for general information on how you use them? I think you may have had a question about how you hook up the grounds. I'm lucky today to catch you live stream. Hello from the Caribbean, Trinidad, Tobago to be exact. Oh, nice. Oh, from the Caribbean. Well, so we have two people here from the Caribbean. Nice. I thank you guys. I'm not quite sure exactly in the world where the Caribbeans are, but I do thank you guys always for dropping in, channel support. I have never in a million years thought that I'd have this many subscribers that I have. I consider myself pretty boring and dry, so it's nice to know that people are interested in learning amplifier repair. I would show you guys the image, the camera that shows you the whole workbench as a whole, but it's unplugged because I think earlier today it was starting to overheat. So I don't have that camera active. I've almost got all these screws out, guys. I know I did not have this one pulled apart ahead of time. I kind of did some multitasking today, so I'm trying to get more videos put out and released. What I can say about Stetsom is they have plenty of screws in their amplifiers. But I do have another video that I will be putting out. It's about the Smart 5 repair that I did today. Did they really put screws underneath the fans? Did they? That doesn't surprise me if they did. Let me check real quick. I don't want to get defeated by... No, they didn't. They didn't put screws underneath the fans. Alright, let's hold this thing in. This is the first Stetsom Vulcan that I've had in of this style. This is why I'm doing a live stream on it. Just so you guys can have an idea that these are relatively the same as any other Brazilian board. Yeah, thanks. Welcome back. Never use one but want to get one. Oh, for the scope? Yes. If you are going to be doing any repairs of Class D amplifiers, I highly recommend. I have dogs too, guys. They're just big black lab, like to make a lot of noise. Sorry for anyone that's wearing headphones right now. Oh, I see what they did. So these plastic end trims, they wrap around that heatsink. Nice, nice. Thank you, Stetsom. Let's see here. This is cool. I get to see what's wrong when I See, this is cool. I get to see what I did wrong or missed trying to fix that amp. SS Steve. What I did wrong or missed trying to fix that amp. Are you working on one, Steve? And I get scared about natural, and I get scared about natural. Are you talking about the you get scared about electricity? If there's one thing that I do recommend when it comes to amplifier repair is knowing, having a good understanding of the fundamentals of electricity, because these things pack a ton of voltage that really can give you a bad day. So as I always say in my videos, to keep your fingers out of the rails, because the voltages on these rails can be in excess of 180 volts, which really could do some damage to you. So we got this out of the heat sink here. Hello, David. Hello. Thanks for joining in. I know this was supposed to start at 3 o'clock, so I am behind just a little bit. I did have some technical issues, equipment-wise, of course. Let me get all my screws packaged up here. So what does this use? Just to let you know, this does use the SI8244 IC on the output. And if any of you guys have done any hunting at all for the SI8244 ICs, you'll know that they really don't exist. They do exist, but you're going to be paying a hefty price for them. So just a quick rundown of this board. You have the 1404s in the power supply. You're going to have some gate drive ICs right here. This is almost identically set up to a tar amps board. You have two gate drive ICs right in the middle down here. You have the output section here, the amplification side. The IRFB 4115s in the output. 1, 2, 3, 4, 5, 6. So you have 6 and 6, 6 on each side. I always check to make sure I don't have broken inductors. That's a common failure on like the 8Ks and 12Ks. It goes through, it doesn't use any gate drive ICs though. So it doesn't use anything like the 3005s or the, what is that, the UCC 27511 ICs. It doesn't use any of those. It's a direct drive right off the SI8244 IC. And then right down here you have the PIC. And that'll be my biggest question, is if that PIC survived. Oh, hey, thanks, David. Hey, thank you very much for that. I do appreciate that. Any channel support that I get money-wise does help go into new equipment, just to let you know. I will be working harder to get the equipment up to par. Looks like I'm getting a little bit of lag on my video here. I mean, if you connect the natural in the wrong place in the wrong board, I'm fixing TV, laptop, and PlayStation. Oh, yeah. In the wrong place in the board, I'm fixing TV, laptop, and PlayStation. So you're talking about the grounding of the scope? I think of what you're referring to as the neutral of the scope. Yeah, my video is lagging just a little bit here. Well, hopefully it quits buffering. Yeah. Yes, grounding is very important when it comes to scopes. There's a right way and there's a wrong way to do it, and you'll learn really quick when you do it the wrong way, because you'll burn something up. You'll short out the power supply. The biggest thing to understand is that your scope, your ground on your scope. Let me see if I can give you a visual representation here. So here's my scope lead, and here's the ground. So you'll see this on some people's probes. This is grounded right to earth ground. I don't use these because my scope is grounded right at the scope. So I ground my scope to my 12 volt power source, which my 12 volt power source is isolated from earth mains. That's the biggest key there. Oh, is this your amp, Steve? That is amazing. Ah, yeah. Oh, Steve. Now I get it. The first name. Yes. Yeah, this is your amp. That's cool. You'd be the first time ever I've had the owner of the amplifier, I think, on the live stream with me. That's pretty cool. So I'm going to remove the power supply transistors here. Of course, with the good old Hacko FR301. So do excuse the noise. It may get a little loud for anyone that's wearing headphones. From Trinidad. Thank you, Michael, from Trinidad. I try to not be too boring on my videos. I know I've been really slacking on getting videos put out, but I have been just buried in competition amplifiers and tar amps warranty repairs. So yeah, hey Steve, since you're here, I don't know if I got any background on this or not. Was it playing during the failure, or do you have any information on the failure of this? It's not very often you see these Brazilian style boards with power supply failures, unless it was driven with some pretty serious undervoltage. What do you think about the design of the Vulcan amp? Oh, the design of this? I love the design. I have nothing bad to say about the design. This is an identical copy of a tar amps amplifier. So who made who? I'm not sure. Either tar amps or Stetsom. I heard Stetsom came out first with the Brazilian designs, but I'm not 100% positive on that. You want to see what lead-free solder does? Lead-free solder. Plug up your iron really fast, or your desoldering gun. There we go. I am not a fan of lead-free solder. I don't think anyone that repairs electronics is a fan of lead-free. Let's see. But this power supply failed pretty drastically. So it's going to take a little bit for me to get past all this lead-free solder here to clear up these pads. And hey Steve, just to let you know, tomorrow I will be taking care of your tar amps board. You are in line to, you guys, sorry I have that camera unplugged up there, but you're right next to me in line for tomorrow morning. Now that I've gotten past the severely burnt transistors, it'll take just a second to pull these out. I don't see any damage to the rectifiers. I do see, however, though, that this amplifier has been worked on before. Looks like it had some failed traces in the past that someone has repaired, so hopefully everything's still going smooth. Oh, good. I told my wife, I said, you know, one day I'm going to have to get a new computer to support this, all this video that I'm doing. Oh, but that oscilloscope probe, that ground on there, as long as you're at an isolated power source, you just ground your probe or ground your scope to the ground of your power source. But if you're plugged into mains or power source, you don't want to ground your scope, unlike the secondary side of a transformer or any part of that transformer, because you'll just short the transformer to earth ground. Ooh, that's a... Yeah, I don't get many Stetsom amplifiers in really at all. I'm not sure if it's just my location. I've had a few in, but not very many at all. But again, they're all pretty much the same design. One thing I would add on any full bridge amp would be a clip limiter. Yeah, I would think anyone that, you know, drives these larger amps would have more information on that. But from a technical standpoint of view, I mean, clipping is just driving that signal up to your rail or trying to exceed the rail, which of course that'll never happen. That's when you clip. That clip is your DC voltage. So you know, and a lot of amps will have DC indicators or DC protection, but these amps, no, they don't. I touched the speaker wires together by accident. Oh, you did? Oh yeah, that oh, that means that the output then is, hold on, let me check real quick. If you shorted the speaker leads, that means you probably have shorted output transistors, but maybe not. Maybe not. Ah, well, looks like the output survived. That's pretty awesome. Yeah, it looks like the outputs might have survived. Usually when you short the speaker leads, it just destroys the output section, and when the output section shorts out, it takes out the power supply from a dead short. Man, I tell you what though, the thing I could probably say that could be a little bit better on Stetsom's part is a little bit better QA/QC on their final product, I should say. But some of these posts are pretty tall. So while I'm here, I'm just going to work on a couple traces. while I'm here, otherwise everything's looking pretty decent. I know the gate drive ICs are going to be faulty because there's a hole in the middle of them. And they do have some silicone right next to the ICs I'm going to have to cut out of there. There. We don't need all that in there anyways. That will give me access to the gate drive ICs. I'm going to pull the one off that I know that's got a hole in it. Or was that just flux? Nope, that's a hole. Because if we take a resistance measurement here, we will probably see that we have some failed gate drive ICs. 737 ohms, 1K. So that side should read 1K because these are probably using 1K pull downs. 360 ohms. Yeah. That's going to be your gate drive ICs. 66 ohms. 85 ohms. Okay. Hey, good. I'm doing good. Good to see you dropping in here today. I tried to time this live stream to try to catch kind of a wide range of my audience. I notice sometimes if I do it too early, a lot of people are still at work. Oh my gosh, why would they do this? They stuck these things way down in there. See if I can get those things off of there. There it is. There's one IC removed. Way down in there. And the other IC removed. So with those gate drive ICs removed, you can get a better idea of your resistance values when you check them. And the gate drive ICs on these are the 524s. So the 27524 gate drive IC. Let me double check my resistance here. We may have to go ahead and pull all the gate resistors off. But we got to pull out some trusty Q-tips because this board is just too messy for me to work on here. I'm just going to clean up all the soot here so I can see the resistors. I'm pretty sure these are going to be used in the 1K. pull down resistors. I'm just not positive on the gate resistors, if they're following the standard design or not. The last Stetsom I did not follow a standard design. They used some really oddball transistors, and it was just a real nightmare to repair. So the gate resistors on these are they couldn't be using any more of an oddball resistor. A 1.5 ohm. Wow, that's impressive. 1.5 ohm resistor. So I'm just going to make a note of that 1.5 ohm, and then also the pull down resistor. Once I locate one here. So your pull down will be going to ground. 2.198. 2.2K? Yep, 2.2K. All right, so the pull downs are 2.2K. Can you check a diode on there? Can you check a diode on there? Can you check? So we're at, Steve, what are you talking about? .2. So in a circuit that's not going to be damaged, you should read your 2.2K from gate source. .5, 2.3, 14K. Well, that means we have a gate resistor that's out of value there. Oh yeah, so this gate resistor reads 11K. So it looks like we're gonna have to replace all the gate resistors too. Let me just flip it around. I'm gonna check the other side. Clean up the remnants of the transistors. You must have had a fairly substantial power source behind this, which is good, which is really good actually, because these Brazilian style boards require a ton of power to really stay happy. Because remember, my primary goal here is to make sure that the PIC is still okay. So if that PIC 2.2K, so that's what you should read between gate and source, 2.2K, you should see your pull down resistor. The gate resistor is 1.5 ohms, so it's very minute when it comes to reading that 2.2K. So 2.2, 2.2, 2.2, 2.2, 2.2, 3.2. That's probably because the gate resistor is out of value. Gate resistor showing 1K. Yep. 2.2, and then last but not least 2.2, which means that's telling me that the gate resistor is still okay on that one. But again, what I'm going to do, since they're using such small wattage, I should say, gate resistors, is I'm going to replace all the gate resistors. These are the really small what are these? These are the 1/16 watt gate resistors, which, I mean, I don't know. In my opinion, they're pretty small. But I've seen that's what Stetsom does, is they use really small wattage components on their stuff. Kind of like Sound Digital. They use really small resistors on their stuff, which Sound Digital, they won't even talk to me. They say I'm not qualified to work on their stuff. So, all right. So, I'm going to check, make sure I don't have any shorts across the power terminals, because I need to see and make sure that we have gate drive. Oh yeah, charging the capacitors. Now, since there's no power supply transistors in, I'm not worried about rail voltage. You won't get any rail voltage without power supply transistors. And I do have the scope running, which oddly enough is not on the screen because I don't have it fired up. That's right, because I had to restart the computer. Technology. So I should have gate drive if I just bump the power on this. And this is where I'm going to cross my fingers. And of course, before I start any amplifier, I make sure all the potentiometers are fully counterclockwise. Even though I know I'm not going to build any rail voltage. Can you check it out on there? And I replaced the output MOSFET. Oh, did you work on this, Steve? I'm sorry. If we discuss this, I'm sorry. I have a really bad memory. That's why I slap my own hand when I don't take notes. I can't remember. So did you work on this before? Let's see if we have a PIC that survived. I'm gonna hope it did. So I'd hate to tell Steve that his PIC is no longer functional. Most times the PIC is okay. Although I should make sure that the resistors didn't burn up that feed power. 220, 2.2K. So 2.2K resistors on there. They're not open, so that's good. So we don't have any damage there. Switch mode power supply A and B, and they gave us good pads to work with to check the gate drive. Another excellent thing. I do work for Stetsom also, so they're great people too. All right, let's see here. All right, so I do get the blue LED. Let's see, do we get a pulse on this? Although my scope is set at 50 volts, we don't want that. We're going to bring it down to 2 volts. Most gate drives are what, 6 volts. So is this one not going to show me? I'm hoping it'll show me, but it may not show me. Oh, hold on. I do see a little bit. Okay. Don't touch the alligator clip to the 12 volts. Switch mode power supply feedback. Oh, they're using feedback on this. These guys. All right. So everything is active. And I get just a really quick blip on that. Diode under the blue light next to the capacitor. Oh, and our diode under the blue thing next to the capacitor. The diode under the blue thing. Oh, you mean the capacitor here? We have Zener diodes across the output, and hold on. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Oh, yeah, those are Zener. These are Zener diodes. These are 15-volt Zener diodes. So it looks like if this diode got replaced, it's got a black band on it. I mean, I do have black band 15-volt Zeners, but typically those black band diodes are your 4148 signal diodes. But I'm not sure if that's a Zener or not. Should be a Zener. I would like to see a little bit better signal on the gate drive, but it's not going to allow me to do that because it uses switch mode power supply feedback. Yeah, so I'm gonna have to put an IC down to probably even get this thing to even give me a switching signal. Usually I can see a switching signal. With the ICs removed. And I'm just not seeing the drive on that. Probably because it has no feedback. So that is going to be a bear to solder those on, just to let you know. Wow. They had to stick those right in between all those capacitors. Oof. That wasn't very nice. Yeah, not very nice at all. Thanks, guys. Thanks a lot. Well, let's boy, that really Yeah, I keep touching that alligator clip on my on my ground. It just gives just a really, so that PIC really just gives a quick little pulse. I can just see it on the scope. So, I mean, it's there, but it's a really quick little pulse. So I do believe that PIC is good. All right, let's try to do this without having to remove rail capacitors. It'll be tricky. It'll be tricky, but I think it's doable. All right, I need two 27524s. Once I locate my 27524s here. Another IC that is almost impossible to get are these UCC 27524s. So if you guys are looking to repair your Brazilian boards, I would look first for your drivers, and then if the board uses the SI8244, I would be looking for those also, because these are absolutely hard to find. All right, now we just got to somehow fit these back into place. What I'm going to do is I'm going to tack one leg just to hold it in place, and then I will attempt to solder them in. All right. So that's one leg of each IC tacked into place. And then my most favorite least favorite thing to do is to use hot air to put an IC on. But these are in places that are a little bit more difficult to get to. Yes. Oh yeah. Yeah, Steve, yeah. So that, as a matter of fact, I'll go ahead and pull it off real quick here. This this diode here that's got the black band on it is probably a 4148 signal diode, which these are all going to be 15 volt Zener diodes. which is just a standard design of Brazilian boards. So what that does is it heats up the pad underneath the IC. When you heat up the IC like that, it necessarily doesn't mean that the legs of the ICs are soldered down, but there is a pad. There's a pad right in the middle of that IC. That's the kind of like the heat sink for this chip. And when you apply the hot air like that, and I'm pushing down at the same time on that IC, not too hard, you don't want to deform the chip in any way, is you're just seating the heat sink of that IC down to the board. And then I have to reach in there with my micro soldering iron and solder each little pin of that IC to the board itself, which again is going to be a little tricky to do just due to the location of the drive ICs. Time is at 4:12. It's been an hour and I'm 15 minutes behind. All right. So can I get this done? I doubt I'm going to be able to use my standard soldering iron. The thing with these really small SOP chips is it's really easy to create solder bridges if you don't have that little fine micro pencil tip, which I don't think I have. Let me check. Let me check. I may have one here. Well, I got one that's a little bit more fine point. That way I don't have to try to drag this over to the other bench while you guys are watching. Let me try to change the bit here. And I'm going to try to solder this in place with my Haco FX888 iron. So I'm probably going to have to slide this just off the camera just a little bit so I can get my head down in there and see what I'm doing. In the meantime, while that iron is heating up, I will clean up the output section here. So that's probably why I don't show any shorts, is Steve, you've probably already replaced the output transistors? Or is this factory? No, that's not factory. Oh yeah, cleans up nicely. Yeah, I'll go through and I will we'll get that Zener replaced. I do have 15-volt Zeners, and then we'll check the resistance of the 15-volt Zeners here. One thing I did notice though on this capacitor is it is bulged on the side a little bit, and I'm not sure if that is from a short or not. So that's something I will be keeping an eye on when it comes to checking all my values. All right, let's see here. Let's go ahead and change the camera view. Let's see if we can get right down in there. Can't quite see the area that I'm working on. There we go. All right, as you can see, there's the two ICs that I need to solder right there. So I'm going to try not to solder bridge anything or melt any capacitors. All right, here we go. So far, so good. These are absolutely some of the hardest places to try to even solder something. Whew, that is a really, really tight little spot there. So I need to looks like I do have a small little solder bridge here. Boy, that is just fighting me. Fighting me left and right on that thing. All right, hold on. Not the easiest place to get into, that's for sure. Hmm. Yeah, the one thing I didn't want to have happen is the good old infamous solder bridge of the pins. Yeah, I'm gonna have to pull this over to my other soldering station. Because I'm not sure I can pull that off. Yeah, the joys of soldering small components like this is even the smallest solder bridge becomes the biggest headache. All right. And the only other real way to do this would be to, if you really wanted to clear out this room, is to pull the rail capacitor. But I really don't want to pull rail capacitors to have to do this, so I will avoid that. I will avoid doing that if I can. Whew. I tell you what, that is not the easiest thing in the world to do. So this is what we call like the daily struggles of amplifier repair. All right. One more time. Whew, there we go. Yeah, that took 500 years to get that done. All right. So there's that little guy back in place. And then of course what I do from here is I make sure I don't have any shorts. Nice. No shorts. No shorts. And no shorts. There we go. Now we're getting some pulses here. Yes, all right. Yeah, all right. So we have gate drive ICs back in place. So from here, all I got to do is change the gate resistors, which are 1.5 ohms at 2.2K. And it looks like just replace the one Zener on the output section. Let me just double check here. Let's go back to the other view here real quick. I just want to double check. So 11K, 11K, 7K. So then we should be 11 and 7. So 12, 12, 11, 11. Oh, I think we still have something shorted over here. So more than likely it's going to be the Zeners. Oh no, 11, 11. So what did I say it was? 11 and 11 and 9, 12 and 12. Hold on. So let me check this Zener here. 9, 9. Ooh, this may be. Hold on. I do have a value that's off here a little bit. Ten and 1. So 1 and 10. Oh no, so we're good. Sometimes that's an indication that the drive IC 10, 12, 12. I mean, it's really, really close. 12, 11. So the best thing here would be just to get the power supply up and running and see what my amplitude is on the gate drive coming from the IC here. So again, what I'll do is, it looks like this is the side that failed. I'm going to go ahead and replace all the Zener diodes. You always want to make sure the Zener diodes are correct. But I'd have to pull all these transistors to really know for sure if those Zeners are correct. .6. So what size pull down or gate resistor are you using? 3.6, 3.5, 3.5. Boy, I tell you what, Stetsom uses oddball values. 3.5, 3.6. So that's what I'm going to do is I'm going to replace the gate resistors, put new power supply transistors in, and I am going to fire this thing up and see what my amplitude is on the output section here. It's 4:30. My time for business here is getting real thin here. Again, I do apologize for being late on my equipment today. But I need to see if I even have the 1.5 ohm. 1.5 ohm, which is really odd. So I don't know why they're using 1.5 if they're running standard 1404s off of the UCC 27524. But I'm probably going to pick up on this tomorrow, because I need to round up these really, really small gate resistors. I don't know if... Yeah, I don't even think I have that size, but I can get them pretty quick. But otherwise, and I gotta check this capacitor. So I need to well, here, let's just do this. The Hacko is still up and running. I am going to check this capacitor real quick because it's bulged out. And if that capacitor is damaged in any way, I need to get a new one. Oh, I probably have these. So this is the 6.8. Oh yeah. 6.8 microfarads. This is the same capacitor that Sound Digital uses in their amplifiers. Again, thank you, Sound Digital, for working so well with me. Let's see here. So I'm just going to hook this up here and see what we have here for capacitance value of this capacitor. Oh, it's not bad. I mean, it's 7. It's really close to the 6.8, so we're still good. 7. So that's just probably a factory deal there, that little bulge on the side. So I'm not worried about that. And then that gives me some room to work with the Zener diodes here. And to clean up this board a little bit, I'm going to remove this wire. Is that a wire right there? Just so I can see what's underneath of it. Oh, okay. Yeah, I do see, Steve, that it did blow the traces out. But never fear, that will be repaired. So, Steve, I will have this back up and running before you know it, and I will have your tar amps done tomorrow morning. The tar amps is a warranty repair, so I have everything good to go for that, approved for the repair. So I will have that done, and then I should have this up and running tomorrow. There are several amplifiers in line for testing, though, so it'll be just a little while before I can get you on the bench for testing, but at least the amplifiers will be complete. And yeah. Oh yeah, hey, no problem, Steve. Hey, thought I finally get to see you. Hey, Joe. Oh yeah, you do. Hey, good to see you here. Yeah, It's been an interesting board to work on, Steve. So I'm not sure. Ooh, it got hot because all your solder mask is just flaking off. But yeah, it definitely got hot. And this capacitor, it tests fine. It tests at the right capacitance. So I still wonder about the transistors though. So I think what I'm going to do is probably just replace this bank of transistors just to be on the safe side, unless these were new. I don't think. Let me see the date codes on these. So B9P0, BP, so EK, 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 EK. So were these new transistors, Steve? Oh, will you do a video on how you test the amps? That would be great if possible. Yes, it was like fireworks. Oh, I bet. I could imagine this just by looking at this. This thing went up in just a blaze of glory. Steve, are these new transistors? These 4115s here in the output? You know, Joe, the only thing about showing you guys how I test, I have a really big room here that I do all my work. I don't have any cameras that point to the other end of the area to show how I test things. I don't even have cabling long enough to get a camera over there to show you how I test. So what I can tell you is I use three Dell 240 amp server power supplies as backup. I use a Taramps TEF 240A power supply to charge a full bank of lithium iron phosphate batteries. And then I use a load bank that is it's Canthal wire that's in ceramic tubes, or not ceramic, quartz tubes, immersed in oil. So it's a huge oil-cooled resistor is what it is. That's how I do my testing, just as a roundabout way to give you an idea. Otherwise, it's really hard for me to show anyone how I test because of where it's located. Yes, so they are new transistors. Okay. I was just asking because I do have some odd values between the two sides. So I just, I guess the biggest thing is to make sure that I don't know where you got these from. If they're reading different because they are just have been punched out differently from the manufacturer. If you want, Steve, I can replace them just to make sure that they are good, strong 4115s. Or if you shoot me an email and let me know where you got these from, or if you want to type in the chat there, if you got them from Mauser or DigiKey or wherever you rounded these up from, it'll give me an idea of the internal resistance values of these. And then, Steve, hopefully you haven't felt like you've been waiting forever for these. Like I said, I'm still about 4 to 6 weeks from the time they arrive to get them back out. Yeah, these gate resistors are done for. 1.1K. Yeah, that won't switch a transistor very well. 414 ohms? Oh my goodness. All right. Darn it. See, the thing with these gate resistors, I this is something I overlooked initially, is the size of the gate resistors, physical size. So I need to dig in my inventory to see if I have these small gate resistors in this particular value. That's what's going to be the headache of this, is this is almost like a sound digital copy, or sound digital copied this, but these gate resistors here are not common size resistors. So by removing these two, that'll allow me to check these pull downs. .188. Hey, doing good on that pull down. Where's the other one? 2.18. Perfect. Those pull downs are great. And just one more quick check of the other side of the gate resistors. I think these will all survive. No, they didn't. I was wrong. Oh no, 90 ohms. Okay, yeah. So they're not open, but they're open far enough where I would never run a transistor on these. So 1K, yeah. And no rush. I'm not using them right now. Oh, hey, thanks, Steve. And that's the thing too, is I'm very like to be really meticulous with my work, and I don't like to get in a hurry. That's one of those things where when I get some customers that just bug me about when they're done, and like, well, I'll be done when they're done. But taking your time and making sure everything is right just reduces the return rate. You know, I will always take care of my customers, always. Customer satisfaction is always a priority. So it makes me feel real bad when an amp has to come back for some odd unknown reason. But I will always fix an issue if there is an issue. It's very, very rare that I have an issue. Kind of like in the video that I just made today, I had stated, you know, my return rate is less than 1%. Way less than 1%. About probably one out of every 30 amplifiers I might have an issue with once they get back to the customer. I don't test amplifiers at 16 volts. I will not test amplifiers under the recommended load by the manufacturer. So if you send me a 1 ohm amp, I will test it at 1 ohm. I will not test it at half ohm. I won't even consider it. I test all my amps at 13.6 volts. 2.2, 2.2. These pull downs are perfect. All the amps are tested at 13.6. I can go up to 14.2 if you would like me to. But 90% of all the amplifiers that I service are amplifiers that go in what I call normal vehicles, that just have normal charging systems, normal operation. I know when I get a competition amp in, I can usually tell by the size of it and how it blew up that I know that they're running a higher voltage, so I'll test those at 14. But otherwise, I will not test under manufacturer recommendations. So good power supply. This is actually looking really good. I'm really pleased with how this is really turning out. Next biggest thing to keep fingers crossed are these SI8244 that, oh man, if any of those are bad, that's going to be not very nice, because they are super expensive ICs to get right now. Just cleaning up my flux down here on the drivers. And I got plenty of flux down there. Sorry about that. I'm clocking the old camera there with my head. Let's see. Are you going to fix the SoundStream 14K live? Ooh, live? I might do it live. The thing about these big amps is it's really hard for me to get a view of the amplifier on the bench. So everyone that's still around in the live chat there, Steve has a really nice SoundStream 14K that is in for repair. Just a spectacular amplifier that if I can get on live stream, I will. If not, what I'll end up doing is I will end up making a video on it and editing it just to fit in the best I can in the view. But that SoundStream amplifier, just put 4 more of these side by side, and that's the length of that SoundStream amplifier there for you. So I have no way to check the SI8244 IC right here. I have no way to check that without power. I could probably introduce some rail voltage externally through a power supply and all that, but it's just easier for me to get the power supply up and running, give it some rail voltage, check the switching and make sure, and then see what kind of switching signal I get. So then I'm just going to use the Hacko gun here to clean up the pads. Discharge the power supply capacitors there. And this is something that I also went over today on the video that I'm going to be putting out about that Smart 5 that I did today. I just wanted to get this one on a live stream because this is going to be the first 8K Vulcan that I have had on the channel for YouTube. So what you see on my channel is a small fraction of the repairs that I do, just because it takes so much longer to repair an amplifier if I'm shooting a video than it is just fully concentrating on getting the repair done and not having to go back and forth between live stream and repairing. And we don't want to hear that. Are you going to? No, we don't want to hear. And hey, everybody, I'm not blowing all the amps. I'm getting blown. I'm getting blown already. Just this one. Oh. Yes, live stream. Steve's got 3 amplifiers in for repair. So it's a pleasure, of course, to repair your amplifiers for you, Steve. I promise you that this amplifier, if the output section is good, I promise you this amplifier will be just as good as when you got it from the manufacturer, if you got it from the manufacturer. Just as good, if not better. One of my biggest pet peeves about this particular style of board is the lack of securing of these inductors. See how you can move that? See how you can move these around? I get so many of those in where the inductor is just broke off the board. And it's just annoying to see that because it just takes a little bit more E for effort glue those down and help prevent the failure to begin with. It just blows me away. So and I'm going to clean up these pads. Oh, what time is it? 4:56. All right. I'm gonna have to be taken off here. Again, I do apologize for starting late. I'll remember in the future that after I'm done recording a video and then rendering it, to restart the computer. So that was my mistake. I did not know it would do that. I mean, it was a pretty long video. So the video I'm going to be putting out is an hour and 10 minutes. Because I've had several questions about Smart 5 amplifiers lately, so I figured I'd shoot a video and get it released on the Smart 5. I'll have to send a message to Stetsom and see if they'll send me parts for these things. Like I said, I work for Stetsom, but they have not sent me parts. I work for them in a different capacity right now, other than their warranty repairs, because of the lack of available parts right now. So I do some sound testing for them, interference testing, and also I'm working on being part of their repair and resale program. So thanks. I was able to fix the Rockford Power 300. You saw the pictures. Oh yes, Joe. Oh yeah, that's you. Sorry, I deal with so many people. I deal with a lot of people in even a single day. I forget who is who or who's doing what. That was an excellent job there, Joe. Thumbs up to you on that Rockford board. Great job for your first. I think that's your first board repair. In my opinion, couldn't ask for better. So, thumbs up to you on the repair of that board. Rockford Fosgate in general is just a real nightmare board to begin with. The earlier boards aren't as bad, but man, some of these newer Rockford Fosgates, I shy away from them. So I don't like their design, kind of like Kicker. Some of their Kicker amps I don't like. JL I don't like. Just the design of those. MTX. I have an MTX Thunder that I'm doing right now that, oh my gosh, like why? I ask that question a lot. Why do the engineers do this? So it's 5 o'clock, guys. I have to take care of emails and invoices still. So I do again apologize for being late on this stream. I promise I will work harder to make sure that doesn't happen again. So this is about good to put back together and power up. I just need to find those gate resistors and get those in. Everything else looks great. I get the pulses, real quick pulse on the gate drive ICs, because this does use a feedback circuit. So if it doesn't see a feedback, it's going to shut down. And that's what the feedback does. So I have full confidence that the PIC is still okay. Well, at least for the power supply. Won't know until we power it up. But typically when the outputs fail and when it surges back through, if it doesn't destroy the output IC, that SI8244, then most everything else in the preamp is okay. It's just those drastic failures where it makes it past the drive IC is when things start to get a little bit iffy. Because from here it goes back through, they're probably using a 319 here, which creates this square wave to drive the two ICs coming from the PIC and preamp. So, you know, a lot of things happen if that surge gets further back. Oh, what is this? What is that? Oh, come on, Stetsom. Why did you do that? All right, so before I go, I just want to show you something real quick. This is what I despise. Let me switch cameras here real quick. All right, hold on, guys. I'm going to show you something. Now, if you work on Brazilian boards, any full bridge board, I should say, and we're going to go right over here. We're going to take a little trip across the preamp, or, well, that's the output section. Those are the two SI8244 ICs that I always talk about. Most expensive thing in the amplifier right now are these two ICs right here. $110 each is what my quotes are from my current suppliers. So these ICs directly drive the transistors, your output transistors. And we're just going to keep on moving here. We're just going to scoot right on over. I'm going to show you what I'm complaining about right now. Stetsom, why? Why did you do that? So this potentiometer right here is to set your DC offset. Well, they glued it. What is this? What is that? Stetsom, come on. What is this? So when you change output ICs, when you change output transistors on a board, you have one original set and you put a new set in, there's going to be a slight variance between the two sides on the drive. And that variance on your sine wave, or your switching square wave, will create a DC offset. And that potentiometer that they glued, when you turn it, brings those sine waves back into alignment, so you have 0 volts DC offset. DC offset is when you turn that remote off, or you pull the remote wire and you hear the pop in your sub. It's because that DC voltage that jumps up to rail is going out to the sub. And that offset control brings that to a 0 volt state, or really, really close. I can get down to 0.002 of a volt DC offset, and you'll never hear that sub pop. But they glued that potentiometer, so I'm going to have to find a way around that. Hey, thanks, Joe. Thanks, Joe, for dropping in. If you have any questions about repairs, Joe, please, you know me. Feel free to email me. I'll always get back to you. So that's the quick rundown of this board. I will be back. You guys will see a finished version of this. Hopefully, if all goes well, I will have a video on this particular amplifier finishing this up. And Steve, I will try to get your SoundStream board on video some way or another. And I will also shoot a video on your tar amps repair. I can't quite remember what had failed on that, but we'll get a video on that too. So I do thank you guys for watching. It's 5:04. I gotta go. I got other parts of business I gotta do and take care of. You know, gotta keep the customers happy. So I do thank you for watching. Again, Brazilian board, simple setup. Please keep your fingers out of the rails if you have charged the board. These capacitors here will give you a bad day. Thanks for watching. Links down below, my affiliate links for any products. Thanks for your support. Keep your fingers out of the rails. Stay safe.